Is God hiding in the middle of the galaxy? The James Webb Telescope has now revealed the first real image of the Whirlpool Galaxy, and you might think you're looking straight into the face of God. The glory and majesty are overwhelming, and the new super telescope once again completely outshone anything seen before. Thanks to these never-before-seen images, galaxies are the beauty of our universe. The grandeur and beauty of these vast collections of stars and planets is almost unbelievable. When we look at galaxies like the Ferris Wheel Galaxy or the Whirlpool Galaxy, it is impossible to believe that these formations are pure chance. The geometric shapes, colors, and spectrum of the galaxies seem to be born directly from the divine plan. The James Webb Space Telescope will once again show us many of the most beautiful galaxies in the universe in unprecedented quality and beauty. Check out this amazing galaxy. The Swirl Galaxy is 27 million light-years from Earth. Hubble has already wowed us with its images of this galaxy, but Webb is setting new standards with its brand-new images. The viewer of these images is literally drawn into this galaxy like a celestial painting. Its twisted arms are spread behind the tire. This galaxy tells us the story of billions of stars born and lost in the game of time. The bright red comes mainly from the older stars in the galaxy. These stars have lower surface temperatures and appear reddish because they shine mainly in the red and infrared parts of the electromagnetic spectrum. Some fascinating red structures also arise from hydrogen gas that is ionized by radiation from hot young stars, and then returns to its neutral form. Flashing yellow shows us regions of active star formation. Astronomers call these regions H2 regions, and they consist of young, massive stars that are extremely hot. These stars radiate intensely in the blue and ultraviolet parts of the spectrum. They appear yellow because their radiation is scattered by gas and dust. These regions are found throughout the spiral arms, where many new stars form. The spectacle of a kaleidoscope of colors and shapes was first discovered by Charles Messier, an astronomer of the 18th century. That is why experts also know the Whirlpool Galaxy as Messier 51a. If you look into the night sky, you can spot it with good binoculars near the slightly better-known constellation Boötes in the constellation of the Hounds. The Messier telescope in 1771 was not even good enough to recognize the full glory of the galaxy. It wasn't until William Parsons identified the unique spiral structure nearly 100 years later that the unique features of the galaxy began to be appreciated. The Whirlpool Galaxy is unique in many ways, because it not only shows us a wonderful spiral arrangement of stars, but also its interaction with the neighboring dwarf galaxy NGC 5195. It is likely that the dance between the two changed the shape of the Whirlpool Galaxy and gave it its characteristic appearance. For astronomers, the galaxy is one of the most fascinating objects in the James Webb Telescope universe. The James Webb Space Telescope has been delighting us with image after image since its launch in the summer of 2022. Named after former NASA Administrator James E. Webb, it is one of the most impressive telescopes ever built. This telescope is not only technically superior, but also a milestone in the international collaboration between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. JWST was designed to push the boundaries of astronomy and provide even deeper views of the universe. At the heart of JWST is its 6.5-meter main mirror, which consists of 18 hexagonal gold-plated beryllium segments. This impressive mirror collects incoming light and directs it to the various scientific instruments of the telescope. One of these instruments is the near-infrared camera, NIR-CAM, which is specially designed to capture infrared light. It has 10 sensors that cover a wide light spectrum from visible light to near-infrared. The NIR-CAM plays a crucial role in controlling and focusing the primary mirror. The mid-infrared instrument, MIRI, operates in the mid and far-infrared range. MIRI is a combined instrument that includes both an infrared camera and an imaging spectrograph. Thanks to its deep infrared imaging capabilities, MIRI can reveal details of distant galaxies, nebulae, and stars that were previously invisible to other telescopes. Another exciting telescope technology is the near-infrared spectrograph, NIR-SPEC, which can be used to study the spectral lines and chemical composition of celestial bodies. Thanks to NIR spec technology, we can precisely analyze the atmospheres of exoplanets and distant galaxies for the first time. TO protect JWST's sensitive instruments from the sun's heat. The telescope is equipped with a 5-layer sun shield. Only thanks to this solar protection, the instruments in space can be kept at the low temperatures necessary for infrared observations. The James Webb Space Telescope was launched into orbit in December 2021, much further than Hubble. The telescope orbits the Earth around the second Lagrange point, located about 1.5 million kilometers from Earth on the opposite side of the Sun. The position of the telescope is ideal to have an excellent view of the universe and to operate in a stable environment without the disturbing effects of the Earth's atmosphere. In just 1 year, this telescope has already produced such amazing images and scientific discoveries that scientists and amateur astronomers are excited. The years of delays and the cost explosion caused by the long launch have already paid off. James Webb gives us more amazing glimpses of cosmic beauty and diversity and helps us solve the greatest mysteries of modern science. What information do we currently have about stellar regression? The Whirlpool Galaxy has strong star formation, especially in its visible spiral arms. This galaxy is thought to produce stars like an assembly line due to its intense interaction with its companion galaxy NGC 5195. During this interaction, gas and dust condense in the spiral arms, creating ideal conditions for the formation of new stars. It is here in the star-forming regions that the effects of stellar feedback occur, which scientists now want to better study with the James Webb Telescope. Stellar feedback is the process by which existing stars in a galaxy influence the formation of new stars through stellar winds, stellar explosions, or UV radiation. Stars are constantly ejecting matter into the surrounding space in the form of gas and dust. These ejected particles can collide with neighboring gas clouds and compress them, stimulating the formation of new stars. Another variety is triggered by supernovae. When massive stars explode at the end of their lives, they throw huge amounts of energy and matter into space, compressing nearby gas clouds and turning them into new stars. Did you know that stars emit large amounts of ultraviolet radiation? This radiation can ionize hydrogen gas and turn it into so-called H2 regions. In these regions, the conditions are ideal for the formation of many new stars. The Whirlpool Galaxy is one of the best examples of these processes, and thanks to the James Webb Telescope, precise measurements of the processes in star-forming regions are now available for the first time. This new information has fundamental implications for the evolution of galaxies, because the feedback not only regulates the rate of star formation, but also affects the composition and structure of galaxies. Understanding stellar feedback is an excellent example of the interaction of stars, gas, and dust, and all the processes that shape the immense beauty and diversity of the universe. Where do most stars form in the Milky Way? New stars are constantly being born in our own galaxy, the Milky Way. Star-forming regions are characterized by a high concentration of gas and dust. The Milky Way has many such regions, including the Orion Nebula, the most well-known and visible star-forming region. There are two main methods of forming stars.
According to the theory of collapse, part of a large complex of gas and dust clouds collapses under the influence of gravity, forming a protostar. The trigger theory uses existing stars or internal disturbances such as supernova explosions or interstellar shockwaves to compress gas clouds and trigger the formation of new stars. In the Orion Nebula, gravitational interactions and compression of gas are likely the driving force behind the formation of tens or hundreds of new stars each year. As soon as stars are born, their radiation and winds trigger a feedback effect on the environment that favors the star generation process. The study of galaxies and the universe as a whole has always captured human curiosity and imagination, from the ancient times when the stars were seen as gods or divine messengers to the age of modern sophisticated telescopes such as the James Webb Space Telescope. JWST. Our quest to understand the cosmos has been relentless. Each new discovery, each deeper understanding of the vastness of space brings us closer to answering fundamental questions about our existence and the nature of the universe itself. Launched with great anticipation and fanfare, JWST represents a giant leap in astronomical observation. Its advanced capabilities allow astronomers to peer deeper into space and further back in time than ever before. By detecting infrared light, the telescope can reveal hidden phenomena obscured by dust clouds or the distant atmosphere. This ability is crucial for studying the mysteries of the birth and evolution of galaxies and exoplanet atmospheres. One of the most fascinating aspects of galaxy observation is the interaction and merger of galaxies. Galaxies are not static entities that drift in isolation. They interact with each other through gravitational forces, sometimes resulting in spectacular collisions and mergers. These interactions can trigger powerful bursts of star formation or lead to the formation of new hybrid galaxies with unique structures and properties. The Whirlpool Galaxy, also known as Messier 51a, is a prime example of such an interaction, with clear signs of gravitational disturbance from its companion galaxy NGC 5195. The study of galactic interactions provides important insights into the dynamics and evolution of galaxies. When galaxies collide, their gravitational forces pull each other's stars, gas, and dust together, creating tidal tails, bridges, and other remarkable structures. These interactions can lead to the formation of new stars in regions where gas and dust are compressed, as seen in the Whirlpool Galaxy. Understanding these processes helps astronomers connect the life cycles of galaxies and the larger cosmic web. Beyond galactic interactions, JWST is poised to explore some of the deepest questions about the origin and fate of the universe. It explores the nature of dark matter and dark energy, which together make up most of the mass energy in the universe but are largely mysterious. By tracing the distribution and behavior of galaxies across vast cosmic distances, scientists hope to infer the properties and effects of these elusive components. JWST also plays a key role in the search for habitable exoplanets and extraterrestrial life. By analyzing the atmospheres of planets orbiting distant stars, the telescope can detect signatures of molecules such as water vapor, oxygen, methane, and other possible biosignatures. These observations can provide important clues about the possibilities of life beyond Earth and the conditions for the emergence of life. Overall, the James Webb Space Telescope represents a new era of space exploration and discovery. Its advanced technologies and capabilities allow astronomers to explore the deepest and most distant corners of the universe and unlock new insights into the nature of galaxies, stars, and planetary systems. The amazing images and data it provides will not only expand our scientific knowledge, but also inspire wonder and awe as we continue to unravel the mysteries of space. When we look at the vastness of space through the JWST lens, we are reminded of the deep interconnectedness of all things and the ongoing human quest to understand our place in the universe.